A very good evening, distinguished speakers and esteemed guests. I'm very delighted to welcome you all to the India Smart Utility Week 2024. I welcome to our next session, that is Emerging Technologies for Utilities in collaboration with DST. We are very privileged to have two panels of exceptional speakers. So our first speakers of the first panel, this session would be chaired by Dr. S.C. Srivastava from IIT Kanpur. The session would be moderated by Dr. J.B.V. Reddy, scientist from DST. May I have the privilege of announcing the names of speakers. Ms. Jemma Green, founder and CEO of Powerledger. Welcome, ma'am. Mr. Nick Birell, Vice President, Industry Strategy, Oracle Utilities. Welcome, Nick. Ms. Nisha, Executive Director, IUSSTF. Very warm welcome, Ms. Nisha. Dr. Om Krishan Singh, Scientist, Government of India. Welcome, Dr. Om. Next is Dr. Suresh Babu Muttana, Scientist from DST. Welcome, sir. Next is Dr. Sathyanarayanan, Sankaran, CEO from Urban Morph. Welcome, Mr. Satya. A very warm welcome to all our speakers. Looking forward to a great session. Now I would like to hand over mic to our moderator, Dr. J.B.V. Reddy, to proceed with the session.
Thank you, Shashi. Now I would like to request our chair, Professor S.S. Srivastava ji, to introduce the session and highlight the relevance on clean energy and its impact in the country. Thank you, sir.
Let me first welcome all of you to this session. So it is slightly late, half an hour late, and there are two sessions which have been planned on clean energy. This is for one of them. And Dr. Reddy will be moderating the session, and we have very eminent speaker from the government side, from the other sectors, who will be sharing their experiences. I think clean energy doesn't need any explanation. Even the previous session, which was on digitization, so digitization effort was on achieving the clean energy goal. In fact, the SDG, which the previous session moderator was talking, 17 sustainable development goals of United Nations, one of them is on clean energy solutions. So it is very important to evolve clean energy. Why it is required, why suddenly it has gained so much momentum, I think it is known everywhere by everybody, and it is because of various pressures which we are facing across the globe. And when we talk about clean energy, it is not only the power sector, it may be energy related to transportation, it may be related to the building, efficiency, and so on. So we should have a holistic view in achieving the goal of clean energy. And why we are worried too much these days? Because of the threat of climate change, which we are experiencing, and everywhere people are talking about 1.5 degrees Celsius temperature rise by 2050, IPCC predicted. IRENA gave also the guidelines that how to overcome that by different sectors. So these are some of the efforts which have been made. So globally it has become one of the agenda that we will develop our energy sector in a cleaner way, in a sustainable way, in a secure way. So without, I think, talking too much from my side, we would like to listen by the experts who are present here. And I will request Dr. Reddy to conduct the session, and maybe the speakers can share their views.
Thank you, sir. Thank you very much for highlighting these clean energy initiatives. Yeah, now I would like to request Dr. Jemma Green to share her views on clean energy.
Good afternoon, everybody. Namaste. Thank you for ISGF for inviting me here. One moment. All right. I'm going to talk to you about intelligent Web3. Intelligent being about AI and Web3 being about blockchain. Who in the room doesn't know what Web3 is? Don't feel bad. IBM did a recent survey of about 50,000 people and found 70% didn't actually know what Web3 was about. So I'm going to take the next 5 minutes to explain what Web3 is up to, how AI plays a role in Web3 and how that relates to electricity. So the first thing is to say that India's consumer market is set to become the world's third largest by 2027, and it's already in excess of $3 trillion. It's very significant amount and growth. And in terms of what we mean by intelligent, well, first I think before we talk about Web3, let's just say what is Web 1 and what is Web 2. Web 1 was like the first draft of the internet from the early 1990s to the early 2000s. And Web 2 came about in the mid-2000s with brands that we know today but were startups at the time like Facebook, Twitter and Wikipedia. And they really empowered users to create their content on the but the content was owned by the platforms. And I think that's really a big characteristic of Web 2. So in terms of Web 3, it's basically a term to describe the next generation of the internet. That's built on blockchain technology and where the community controls a lot of the data as well. And then if you add AI to Web 3, you basically get intelligent Web 3. And there's four basic characteristics of it. The first is blockchain, which is used for tracking and trading information. The second is smart contracts, which performs and executes functions automatically. The third is digital assets and tokens, so that could be digital representations of things like carbon credits or art, etc. And then intelligence powered by AI for forecasting, anticipating demand and making recommendations and things like that. In terms of the Web 2 era, it was really about control by the big tech companies. And in terms of Web 3, I'd say that the big characteristic is where it doesn't rely on a centralised counterparty to move value between buyers and sellers who are interacting with each other. It's much smarter. So in terms of real-world examples, I just wanted to talk you through some of those now. So Nike offers NFTs to customers to access exclusive sneakers, and there are lots of brands doing similar things. The esports brand 100 Thieves offered people that took tokens and created a digital wallet, diamond necklace, and I think more than 300,000 people downloaded that and did that. There's a Web3 application called Helium, which allows you to share internet, and the tokens allow access to your internet and payment for allowing third parties to do that. And then KKR, which is one of the largest investment funds in the world, has actually set up a token fund to invest exclusively in tokenization. JP Morgan has actually created a clone of the Solana blockchain to internally settle between different business units and functions as well. And Powerledger has deployed energy tracking and trading and carbon solutions in many countries, including in India. And the solutions really are around peer-to-peer energy trading, secondary trading of power purchase agreements, provenance tracking for energy, to validate claims made about types of energy, which is becoming increasingly important to actually distinguish whether energy comes from renewable sources or other sources, certification for green tariffs, which can also avoid duplication, which is a big issue, and also blockchain for price discovery, which is suitable for coupling, which is happening in the Indian market. In terms of Web3, how big is it? Like, is it small? Is it big? I'll just try and give you a bit of a sense of that. Firstly, the NFT market is already tens of billions of dollars. I think a growth rather this year, and it's expected to be $250 billion in size by 2030. Stablecoin payments are close to $200 billion already, and they've got 50% growth year on year. The number of Web3 gamers is up 60% in the last 12 months, and the market's already valued at $18 billion. The tokenization market grew by 23% last year and is already $3 billion in size. And revenue from the Indian token market is already $15 billion with double-digit annual growth. And I think if you add AI into this, it really compounds the market efficiency and opportunities by several factors. So what's the relevance of intelligent Web3 to energy? I think is the next question that I want to just talk to you. So the first thing is about ease for customers to participate in events like demand response and also token reward programs and get paid. Smart contracts can facilitate the automation of energy transactions to drive efficiency in processes. Blockchain provides an immutable record to track all of the energy activities, which increases trust in the system. If you want people to participate in it, they need to trust it. And then tokenization can be used within the Discoms ecosystem, but also partner with other retail brands. And that's really important in unlocking more value for the utility sector by partnering. And I think AI makes this faster, more accurate and efficient, and also can segregate data for security purposes. So I think what tokenomics can do is create an economic system where energy is the currency. And loyalty tokens incentivize sustainable practices and help the grid as well. And then the energy tokens can be redeemed for bill discounts like EV charging or goods at partner brands. And then what tokenization does, like why do it with tokens as opposed to not? It reduces administration and it automatically empowers consumers to engage, exchange value and purchase goods and services in new ways. So I think there's like a few different reasons on that. Just to give you a visual on the customer journey, we've got Sanat here. He's an existing Discom customer and he loves drinking chai latte. He also has solar panels on his house. Now, the customer journey, which I'll just talk you through, is he doesn't use his solar while he's in the office, so he can sell that back to the Discom instead of the feed-in tariff, and he gets paid in tokens for that. And once signed up, his smart meter readings are loaded onto the blockchain and AI forecasts the missing readings as well. So he's not waiting days and days to actually do the calculations, and the rewards are in tokens. And then he can then go to his favourite chai latte shop and he just needs to load the QR code as usual and pay with tokens. And this could be used with other consumer products and fast-moving consumer goods as well. So that gives you a bit of a sense of what's possible. In India right now, where I think in excess of 20 gigawatts of renewable energy is being added onto the grid each year, and this is creating renewable energy certificates and carbon credits, but also presenting grid challenges. And I think coinciding with this is the emergence of Web3 and AI, which are new ways of engaging with customers to help the grid and be more customer-centric and also to create more value. And I really look forward to seeing how all of this unfolds in India. Thank you.
Thank you very much, Dr. Jemma. I would like to request audience to note down the questions. Once we will have the presentation from all speakers, then we can have the questions. Now, I would like to request Dr. Nick Birell to give overview.
I need my glasses. Okay, now I can see people. Thank you, Dr. Reddy, esteemed panellists, distinguished guests in the audience. It's a pleasure to be here today and to take some of your valuable time. Hello, my name is Nick Birell and I'm Vice President of Strategy at Oracle Energy and Water. And today I thought I'll use the next 5 to 8 minutes to really introduce you to the services that Oracle offers to the energy industry, especially how we incorporate emerging technologies into our existing solutions, and also then how Indian utilities can actually benefit from this. But first, let's do some background. As many of you may be aware, Oracle was founded on its database some 45 years ago now, and as a result, data is really much part of our DNA and at the heart of what we do. At Oracle, our mission, which we've accepted, is quite simple, and that is to help people, companies, utilities, communities and governments like yourselves in the audience here to see data in new ways and to discover insights and unlock the opportunities within that. And as a result, we are the world leaders in managing big, complex and demanding data loads. In reality, the bigger the better for us. And whilst many people know this about Oracle already, many are still unaware of what we specifically do in the energy industry and how we can actually help people like yourselves. So in the next 30 or 30 seconds to 1 minute, let me introduce you to our offerings to the industry, and then I'll talk about how we actually integrate emerging technology, especially AI. So firstly, we offer what has been described by many analysts as the industry's most comprehensive offering for modern energy utilities. We serve up to and exceeding 550 million end utility customers globally. We generate over 3 billion utility bills annually. And from a decarbonisation perspective, a growing focus for many utilities globally, especially in India, we've delivered over 35 terawatt hours of energy savings to utilities. And this is mainly through our energy efficiency programs and our demand response solutions. Putting that in human terms, that's like taking 3.5 million households off the grid every year. So we do all this by providing market-leading integrated business solutions that span the complete end-to-end business value chain, right from the grid through to the customer, and covering such areas as ERP, capital projects, field and asset management, grid operations, distributed energy, utility billing, and definitely, not last, because it's very, very important for India at the moment with the smart meter rollout, we have a metadata management solution as well. And what happens here, this all runs natively on Oracle's cloud infrastructure with all the benefits of performance, scalability, and of course, that world-class security that you would expect. So in summary, yes, we do offer quite a comprehensive, complete and integrated market-leading solution in the energy industry. And it's because of this exceptionally expansive footprint that we can really start to think really big picture when it comes to how we incorporate all the new technologies that we see coming onto the market now. For instance, with artificial intelligence, including generative AI, our approach is to consider every layer of our solution stack. So from the infrastructure layer, where we actually train large language models, which is particularly important for Gen AI, to the privacy and security know-how to manage the risk associated with this new technology, and there are risks. And all the way to the business application layer up the top, where most of you will experience AI, and hopefully, if we've done our jobs well, you won't actually realise you're using it. And if you do, all the complexity of the technology underneath it, you won't actually realise that it's actually being used to enhance your application. So, our perspective on the AI needs of utilities is that it should tie back to specific needs that help enable users to be more efficient, such as saving time or improving outcomes, and also to enable executives and managers to better manage their utility business. And that could be minimising risks, maximising revenues, or maybe perhaps it's better planning their network. It needs to be business specific. AI built for business is one of our mantras, built for the business of utilities. And our strategy is to deliver the tools and the platform for you to use AI easily, on your own, but at the same time, we're using exactly these same tools to embed AI capabilities deep within our existing pre-packaged offerings. Already, many of our offerings have AI embedded in them, and what you see on this slide here is a sample of AI services that we've delivered and that we've already delivered or in the process of actually delivering. And broadly speaking, they fall into three categories. The first category is the future of customer service. The second category is the future of field and asset service. And the third category is the future of network management. And in doing all this, what we realised for some time is that it's not as simple as developing some really cool AI stuff and then just letting it off in the wild. This approach we found is just absolutely does not work. AI does not live in a vacuum. And there is a saying out there that the sum of two things is greater than its parts. And this is very much the case for emerging technologies such as Gen AI. So our experience to date informs us that the magic, and yes, the magic really starts to happen when you bring multiple emerging technologies together into a single coherent use case that delivers measurable benefits to the business or to the utility. And we've built out many examples that demonstrates this point precisely. And our first example that I want to show you today is autonomous inspections. Combining the technologies of robotics, machine learning, and our asset management solution, we can deliver increases to worker safety, accelerate the identification and resolutions of issues in the field, and at the same time reduce costs in ways not possible if these technologies were not combined. The next example I wanted to show you here is around field service. And in this situation, we've combined augmented reality, HoloLens glasses, Internet of Things, and digital twins. And by doing this, field workers can get hands-free information and assistance in the field to complete their tasks more efficiently. And just the final example that I want to show you here is around call centre engagement. So by bringing together technologies such as voice sentiment analysis, chatbot, and real-time call monitoring, the call centre agent can actually focus more on actually resolving the needs of the customer on the line, whilst in the background, the Gen AI-based guided resolution tool automates and simplifies tasks, generates service requests, if indeed that's what's required, and at the end of the call, summarise the call at the end, allowing the call centre agent to move on to the next call. So in summary with this, all of these examples are examples of the additional business benefits you get when you actually bring things together, multiple emerging technologies, in a coherent way. And I have to say, these end-to-end use cases just don't suddenly happen. From our perspective, from Oracle's perspective, they're the result of really a lot of hard work and consultation with partners and industries from around the globe. And as the title says here, and this is our belief, that innovation is actually a team sport. All the stuff that I've been talking about now and a lot of the other things, this is not something we do on our own. And we don't have the capabilities to do this on our own. You know, innovation comes from when you get together different groups and different teams and bring them together. And that's our approach. In our innovation labs located globally, we bring together, as I mentioned before, utilities and partner technologies, and that's key. At Oracle, we like to bring in partner technologies, as you see in the slide here, and we bring them in to see what exciting sort of use cases we can develop. Our lab, especially our big lab, which is Chicago, which you see up here, that you see on this slide, is also used to showcase many of the use cases that we've built out. It's actually a really super exciting place to visit, quite inspiring with some of the things that actually goes on there. And we've had people globally coming to visit the lab and just love it. So I do warmly extend an invitation to anyone in this room who would like to go and see things there. It's quite great. But in the meanwhile, we're here in Delhi, and if you are interested, please note the web address down below there. Or better yet, we're actually located in booth 14, or in the exhibition hall, so please come and visit us, and one of our guys can even take you through some of these use cases with emerging technologies such as the drone and asset inspection and a few other things, and you can even get to play with it yourselves. So thank you for your time.
Thank you very much, Dr. Nick. Now I would like to request Dr. Nisha Mendiratta to highlight the IUSSTF activities on clean energy.
Good afternoon, everyone from IUSSTF, and thanks Dr. Reddy and Dr. Srivastava for taking up this particular aspect in this very special session. Hearing to the previous presentations, I could understand the importance of these technologies with regard to the utility sector. And from IUSSTF perspective, I would like to just mention broadly about the importance of the emerging technologies for utilities, and especially with regard to the energy sector, what we are doing. I'm just straight away coming up to the partnership which India and US had together with regard to energy, which started sometime in the year 2005. I just thought of picking up this particular idea to make a base with regard to the current sector in energy, and also the kind of linkages we can have with all other partners who are here in this particular special panel. So this particular aspect started in the year 2005 through a US-India Energy Dialogue, which was advanced by launching PACE-R program, which is Advanced Clean Energy Research in the year 2009, in which DST, IUSSTF worked together. And further, it was taken on board in the past decade or so through several initiatives, and I will not go into all those details, but one thing is very clear which I want to bring to the understanding of everyone, that as climate and clean energy leaders, US and India share a common vision to deploy clean energy at a scale during this critical decade, which is mainly to reduce the emissions and going towards the climate change mitigation aspect. Now, IUSSTF, which is Indo-US Science and Technology Forum, it's a bilateral organization which was established more than 2 decades back, and it is being supported by the governments from both the countries. And the vision of this organization is to have excellence in STI space through collaborative initiatives between India and US. And there are many collaborative initiatives which I would be very happy to share with all of you. Our main role is to identify the edge areas that are of high priority for both the nations, and also leverage extensive network in both the countries to bring together stakeholders. And who are those stakeholders? We are working with foundations, federal agencies, academia, professional societies, individuals, organizations, and many more groups who are working in both the countries, having the common thrust areas in mind. And now how are we working? So we are having 5 main pillars which encompass various activities. The most important is scientific network, which is mainly to bring long-term collaborations between the scientific communities. And this we are doing by organizing bilateral workshops, and also there are many bilateral virtual network centers. Through these activities, we try to bridge, or we try to do matchmaking between the common theme and also the researchers and organizations from both the countries. Then the second one is innovation and entrepreneurship. This is again another very important sector in which various areas have been identified, and energy remains one of the most important area. And we have got programs which were supported by Department of Energy in US, and also MNRE here in India with DST. So this is again one of the main portfolio, and also we have got ignition call as well in energy. Then research and development. In research and development, JCERDC, which is Joint Center on Energy Research, which Dr. Reddy has been very actively overseeing the whole program, and PACE-Setter program. These are the 2 programs under R&D which are confining towards the energy goal. Visitation and fellowship, again we have started, conceptualized a number of fellowship programs for researchers, young researchers, and also faculty to visit the places in US in several areas of concern. Energy remains one of the most important area in that, and strategic initiatives. Coming to the energy sector, clean energy sector, as I was mentioning about JCERDC, till now, it has run into 2 phases. In the first phase, the areas identified were solar energy, building energy efficiency, and second generation biofuels, which has brought out several good achievements, and many stakeholders are on board now who are associated with each other and formed a network of stakeholders in the energy sector. And then this phase was extended to another one in which smart grids and energy storage is the identified area. Further to that, PACE-R with DST and DBT, we have announced and we have worked on several fellowships which I was mentioning with regard to capacity building for postgraduate, doctoral and young faculty. And these fellowships are BASE Fellowship, Bhavan, and Biofuels and Bioenergy. fellowships. And one more program which we initiated was Solar Decathlon India, which was implemented by IEEE and IIHS. And in this month only, we had a very nice competition in which the architects, young architects, were identified and awards were given to them with regard to the building, efficient building. With regard to GCERDC Phase 2, I would like to mention here that the priority areas are smart grids and energy storage. And this is one of the major program, I must say, very promising program in which both the government had committed a good investment, and US-India collaboration for smart distributing system with storage project. It was led by IIT Kanpur and WSU in the year 2017. And I'm very happy to say that more than 30 academic institutions, national laboratories, electrical utilities and vendors in the field of clean energy joined hands in this very successful program. And outcomes included lab test beds, benchmark systems, field plots, and we have even demonstrated reduced carbon footprint, microgrid model, and many things are there with regard to skill development in this particular field, having beneficiaries as power professionals, public and private utilities, discoms and regulatory bodies. And on the top of it, there were many internationally acclaimed publications and patents. So I would like to come to the end just by saying a few takeaways from these activities. The collaborative smart grid research component enabled India and the United States to explore and analyze the concept of microgrids and also optimal integration and utilization of DER. The collaborative grid storage research component works synergistically with the smart grid research program, and it also enabled both the countries to explore the contributions of storage, which led to enhanced grid resilience, reliability, efficiency and performance. And most important is the DSO concept in India, which would certainly open the possibility for performing a wider array of functions than distribution system. Thank you so much.
Thank you, madam. Thank you. Yeah, we will discuss more on the DSO and EOSS project in the next session. Now, I would like to request Dr. Om Krishan Singh from MeitY.
Good afternoon to all of you, distinguished speakers, Chairman Sir JVB Reddy Sir, for inviting me on a short notice. Thank you all. Thank you to Smart Grid Forum for inviting on this platform to tell the activities about the Ministry of Electronics and IT. So I'm Dr. Om Krishan Singh. I'm a scientist in Ministry of Electronics and IT. So in this area, basically emerging technology in the power electronics and utilities. So ministry has taken an initiative, National Mission on Power Electronics Technologies, which is basically focused to advanced technologies in different area like wideband gap-based power electronics, renewable energy, microgrids, and e-mobilities, high voltage power electronics, and it has been categorized into different verticals. Like we have taken the exploratory kind of research and the technology which has already been developed. It is in deployment phase and some application-oriented proposals. So some of the technologies has already been developed, deployed, and commercialized to the industry, which is being used in the different fields. So as far as microgrid is concerned, smart microgrids, as you know that these AI, ML, blockchains are coming up to secure and reliable grids. So with keep in the mind, it is being focused, and we have done in many of the activities. We have developed solar-powered grid-connected microgrid ranging from the kilowatt to the megawatt range, and it has been deployed in the different part of the country, including the, SIDAC, Trivandrum and West Bengal with the supports of the state government agency. So these are the some major highlights, what the technologies is being concerned. I mean, where these kind of emerging things coming up like secure and reliability prospects. So all the technology what we have developed, that is the patented, and it is in modular kind of things which can be scalable to the different power rating and all. So it is a, I mean, environment, I mean, conform to the all the standards what is being published in national as well as international. So this forum not only developing the technology, generating the expertise in this particular area with the collaborative efforts from the R&D, R&D institutions, academia, industry. So these are the some major technologies parts that confirming, and these are, as I mentioned, that solar photovoltaic power plants, we have developed these technologies and deployed at different places. So these are the some power ratings, specification of this grid that we have developed. Some of the technology we have taken in the as a part of the initiative, which is the islanding detection using the support vector machines and the current technologies. So these are the some photographs where it has been deployed and it is working there. So as part of this, some parts like in the Kerala, we have developed microgrid, remote microgrid, not only the islanding, it is a interconnected microgrid technology. It has already been developed there and it is working. So grid connected microgrid, and this is the interconnected, which is connected to the DC line. And as a part of this green energy, we are talking as the government is focusing, to introduce green and 500 gigawatt by 2030. So as part of this green house boats, all the house loads as well as their traction parts is also being in green form, I mean developed with the powered by the solar photovoltaic cells, flexible solar photovoltaic cells. So it has been deployed and it is in the discussion phase with the different parts of the country also for deployment in a larger scale. So some of the work is already being done in the battery energy storage system also, which is undergoing, and some of them has already been deployed at different locations. So in as far as power electronics, as we know that currently 90% of the energy being converted from here and there. So power electronics playing very important role. So not only this electrical part, wind power electronic converters, it has been developed under this mission mode program of the Ministry of Electronics and IT. And this is also been deployed, and we are, discussion with the renewable energy departments also to take it forward. So thank you all. In a short notice, this is the brief. And not only this, apart from this, we have a separate program on EV. As when we talk about green so electric vehicle also, we have a separate program for the development of different components, motor, controller, converter, chargers. So this is, that's all about. So thank you very much for inviting.
Thank you very much. Now I would like to request Dr. Suresh Babu to talk about on e-mobility.
Excuse me.
Yeah. Okay, before they put up the presentation, let me start. I'm from Department of Science and Technology. In fact, around 5 years back, NITI Aayog entrusted work of developing electric vehicle charging infrastructure work to DST as well as Bureau of Indian Standards. because electric mobility is a new area. So they requested help of the Science Ministry. In fact, over last 4 years, we have been interacting with different stakeholders, close to 200 people, and also various associations. And as far as infrastructure is concerned, we have come across 4 important questions as far as India is concerned. Number one, there is a big issue of access to power. In case if we want to charge our vehicles, and if I'm staying in a multi-stored building, and it is a big problem, how do we address accessing power to charge my vehicles? Second question that we came across was, what is the optimum charging infrastructure configuration for light electric vehicles? We know in India, more than 85% of vehicles are of 2 and 3 wheelers, and then that is the highest population among the electric vehicles. How do we address optimum charging infrastructure? Third one is, what could be the best fit technologies as far as heavy duty vehicles are concerned, e-buses and trucks?
You can use the PPT.
Yeah, e-buses and trucks. And then the last question is that very important question, how to ensure high level of interoperability in EV charging users. This is very, very important as far as India is concerned, and many new developments we are seeing. A lot of intelligence is coming into charging and energy storage area. And in this case, when we talk about interoperability in the EV charging infrastructure, one is vehicle to charger, charger to central management system, that is like OCPP, and network to network, and then battery swapping interoperability. These are the 4 things which we have discussed during the discussions. And based on this, we have also worked out various standards. And when we look at Indian vehicles, these are quite different from vehicles that are there in the Western country, because our power levels are lower, and then and we look for lower cost solutions, lower cost charging solutions. So, and keeping that in mind, as far as a 2-wheeler is concerned, maximum power that we need is around 3 kilowatt. So DST took an active role in developing light electric vehicle AC charge point. This is a totally indigenous solution, wherein all the intelligence has been transferred to the mobile, that is for authentication of vehicle and then billing and payment. And this particular device was costing around 5,000 to 6,000 rupees, as compared to AC001, which was costing around 38,000, which was being used earlier. And also, we also worked on dual gun charging for electric buses. This is also, I think, from India, this is one of the newer version. This is extension of single gun charging, but here actually both the guns together we can charge up to 500 kilowatt, and we can reduce the time of charging to almost half. And third one, most important one, is that we try to develop interoperable battery swapping standards for 2 and 3 wheelers. Indeed, we came up with 4 standards. One was on common battery specifications, and second one was on common connector systems. Third one was on this communication protocol, and fourth one was on back-end interoperability, that is back-end network. Indeed, these are yet to be published. And the last one was pantograph charging of electric buses. When we look at it, we have different types and sizes of buses across the country. So, and we see 9-meter bus, 12-meter bus, and also the power requirements vary. So what we explored was, why don't we look at a common charging infrastructure which can be used for charging all types of buses, whether it is school bus or even intracity bus, even bigger vans. And then when we explored, we thought of Panto down solution, and then all the standard was developed, which is very soon it is going to be published. And when we look at this, we were looking that, no, why don't we work out techno-economic feasibility of this thing, and why don't we try out this as a public charging infrastructure where government can invest and many players can come in. And these kind of interventions we have done over the last 4 years. My senior colleague, Mr. Sajid Mubashir, was the one who led all of that. And another thing is park bay charging. When we look at in Indian scenario, having a bigger charging station is too expensive. Then we thought of having even when we think of even return of investment, that is also a big challenge. And now the solution that was suitable for, especially for four-wheelers, is having a park bay charging solution, wherein wherever we park the vehicles, then we can plug in and we can use three-phase connection, and then vehicles can be charged. Here the innovation thing is that different vehicles will come with different international protocols, like whether it is a GBYT or CCS or CHAdeMO, and we thought of developing a universal socket which can be able to charge any vehicle that may come to this charging station. And apart from that, we also are exploring to see that can we integrate the microgrid so that the local, suppose 300, 400 vehicles, wherever we park in different locations in Delhi and maybe across the country in different cities. So through this park bay charging, we can address these issues. And this is yet to be, we as from Department of Science and Technology want to explore this in the form of testing and validation, even developing that universal socket. And this is my last slide. Recently, Department of Science and Technology, we have published one white paper on enabling technology-led ecosystem for e-mobility. And we have covered 4 areas within that white paper. One was on battery, and second one traction motors and power electronics, and last one EV charging infrastructure. And this particular document was developed with a series of interactions with almost 200 industries. It is an industry-focused document, and this can be accessed through our website. And with this, I'll stop here.
Thank you very much, Dr. Suresh Babu. Now I would like to request Dr. Sathyanarayanan to power.
Thank you to the dignitaries on stage, the chair and the moderator, Dr. Reddy, and to the audience for sticking around and listening to this. So I'll spend the next 5 minutes explaining to you how innovating for transport and energy systems is trying to help solve 2 major problems that we have. Most of you in this room know that the energy intensity is continually increasing because of the growth that we are facing and the transition that is happening as well. And at the same time, we have to ensure a net zero as soon as possible. How do we do this, right? One of the secrets that Nick was saying is to say innovation is a team effort. How does collaboration play a role in solving the problem, and how is the industry trying to solve this, right? You need to look at the innovations that are happening. They're happening in small pockets, they're happening in large companies, they're happening in many different places. How do you bring these together? How do you accelerate the path to energy sufficiency and solve for net zero as well? So there's no secret to this. It is not just that the collaboration solves the problem, but it accelerates it significantly, not just incrementally. We have seen that. You can see that you can really accelerate if you collaborate, bring people together, and understand how can you achieve complementarity in solution, and how people are able to play this in the larger scheme of things, right? ITES was set up. It was started between India and UK about 4 years ago. We've been doing a lot of small things, and innovating for transport and energy system is a part of the larger UK-India Net Zero Innovation Virtual Center. It was set up between DST and the Government of UK and the Science and Technology Mission. Energy Systems Catapult from the UK is a part of this center. It is in collaboration with the Indian Institute of Science. It is housed inside, so we have access to expertise in terms of research. and inputs. But most importantly, ITES enables innovators and industry stakeholders who want to play in this whole space in different ways to extend the large utilities and provide complementary solutions and extend that and see how they can value add to the grid and scale the whole solution, right? So the innovators play a huge role, and ITES is trying to bring that together between India and UK. So we do this in various ways. One example, this is just one thing that we did, but there's a lot of other examples, but we'll just stick to one so it gives you an idea of. We worked with the DISCOM and tried to understand how do you help the DISCOM discover where the challenges lie. They do have a lot of information, but they do not know how it is changing and how rapidly it is changing. But innovators on the ground, research institutions are capable of doing that. So we're trying to see how do we bring this together. So ITES can support research-focused or innovator pilots. Innovator pilots are a very strong way of demonstrating the ability of people to come together and solve problems. If the innovators are empowered and engaged, and we help them solve the problem, identify the problem, guide them in the right way, and match them to the large network where they can solve this problem. Those pilots are very key to solve those problems, and ITES is trying to do that. It also helps a lot of challenges that the innovators face because we take a systems approach, right? ITES takes a systems approach to the whole energy solution, and we try to help the innovators find their bearings inside this, whether it is connecting with research or connecting with the large operators and the utility companies. How do we bring all of that together and help solve the problem? Because they will extend the large company on the ground and solve certain problems. So the key takeaways to this is whether you are an innovator wanting to work in this collaborative space and want to tie up with some of the other innovators, you can go to ites.org and look up. There are a cohort of 20. We handpick some people and bring them onto the stage to see how they can collaborate. And if you're a large player who wants to see how this grid can be extended, how do you create a challenge or a problem for people to solve, and that can enable, because without the innovators and bringing this team together, it is not going to succeed. So do get in touch, and if you have any questions, we are there. Thank you very much for your time.
Yeah, thank you very much. Any quick questions? We completed our presentations. We have any questions from audience? Yeah, please.
Hello, sir. I am Dr. Jagdish Shivhare, professor and ex-scientist ISRO. I have a general question. Is there any survey or research study that after how many years the electric vehicles will be cheaper than conventional petrol diesel vehicles within the country, India?
Dr. Suresh.
Sir, there is no direct answer, but what I can say is that there are a lot of developments that are happening. And then, as Reddy sir has rightly mentioned, that those days are not very far. And especially the innovations that transform the electric mobility is majorly the battery alone. And now you can see that the battery costs have come down so drastically. And now it is $150 US per kilowatt hour. So it may further go down, and then that determines how actually the costs, whether will come down, overall electric vehicle costs will come down.
Thank you. Any other questions from any? Yeah, please.
Hi, my name is Piyush and I am representing Landis & Gear. I have one question regarding the stations that we are developing for battery chargings and e-vehicle chargings. Currently, we are having two types of charging methodology. One is the slow charging and the fast charging method. So how these the current infrastructure which we are right now implementing for EV chargings, can be used or reused in future for the fast charging or other mechanism which come in future?
Yeah, actually, as far as 2 and 3 wheelers are concerned, so far we have AC charging as an option. But recently, you must have come across that Ether Energy came out with AC and DC connector. So we'll be able to charge faster. Type 6 and Type 7 connectors actually meant for DC charging. And so that is one of the areas where actually a lot of work is happening to develop these connectors suitable for India, and then so that we'll be able to charge 2 and 3 wheelers. As far as this heavy duty charging infrastructure is concerned, as right now, as I mentioned, that single gun charging takes a lot of time to charge almost 324 kilowatt hour battery. That's a huge battery that is placed underneath the bus. And then that's where actually this dual gun charging has been introduced. The more and more power goes up, then we need cooling system for these chargers. So, the alternative, the dual gun in a way address the charging time issue. And then if India takes a forward step, then pantograph charging will be an excellent technology, because this was proven in the railways. Railways, it was already proven. So considering the number of buses that government want to roll out, yeah, you must have seen in the newspaper, even the number of buses that are going to be rolled out in different states. And these kind of rapid fast charging technologies are very much needed for our country. But at the same time, we need to be cautioned that do we have the batteries that can withstand those kind of high power charging. And so we need to work in both ways. One side charging technologies as well as the batteries that can take up that kind of heavy charging. So LTO is one of the options that have been explored, especially for the e-buses. So it can, it is one of the best options, but still many things going to come out in future. Thank you.
Yeah, thank you. I have a question for Dr. Jemma Green. Yeah, you are a co-founder for Powerledger, and also you were made UI FinTech Entrepreneur of the Year in 2018. Yeah, we would like to understand more about what is your journey to reach that level, and you would like to share something about you? Yeah, maybe some young people are here. That will be benefit.
Sure,
yeah.
Thank you for the question. I'm Australian, and we moved Powerledger 7 months ago from Australia to Switzerland. So my family, my husband, 3 kids and our dog moved to Switzerland. We did that because there actually wasn't a lot going on for Powerledger in Australia. There's more happening in Europe and India, and with 3 young children, 3, 5 and 8, travelling from Australia to these places was like quite a burden. And so when we set up, the company's 8 years old in May, and when we set up the company, as a software company startup, you have to prove that you can build anything. So it's first proving up that you can build something. And then once you build something, and the first projects that we did were in New Zealand and Japan and Thailand, and rightly so, a French company or an Indian company doesn't really care about that. They want to know whether you can do it in Europe and India. And so we ended up building a lot of lighthouse projects in different countries, and we got up to, I think, 14. And then probably in the past 2 years, we started to form a view where there were the biggest opportunities for scale. And India is one place. There are probably 4 countries in Europe and the US. And so we're now focusing our efforts there. And in doing so, it made sense to move the company and myself and my family closer to the markets in which we operate. So it was great to just get on one flight direct from Zurich to Delhi during the day. Yeah, it was a very nice experience not to have to have a lot of connecting flights and a longer journey. And then in terms of the focus, as I mentioned, in the US, the focus is renewable energy certificate marketplaces. In Europe, it's peer-to-peer trading of electricity and provenance tracking. And I think in India, we've done 6 projects here with discoms and utilities. And I think here there's so much so many new things forming. So there's a real appetite to experiment. But I'd say that I noticed a real arc, and it was great to see the presentation around Indigenous solutions here. I just loved how confident India has become around originating its own solutions that are totally fit for purpose for its market, but at the same time being really welcoming to outsiders to integrate and offer solutions in this market. So yeah, it's been a great, I didn't intend to set up Powerledger. It was a bit of an accident. I actually had just had my first child, Amelie, 7 weeks earlier when I met my business partner, and 3 months later we decided to set up Powerledger. And then had two more children while running the business. So it's been like an intense experience, but a very rewarding one. And we were joking, my daughter Amelie, her first word was solar panel. Yeah, exactly. 2 words. Thank you.
Thank you. Thank you very much. Any question from audience? Quickly. Do you have any question? Yeah, please. We will have only 2-3 minutes.
Yes, sir. Yeah, I'm Jemma from Srivastava. I need one question to the Suresh Babu Muttana. Yes, sir, you have explained a lot of the wired charge and the pantograph charge, all the things. What about the scope of wireless charge and dynamic charge from that scope is there? And what about the support from DST side and Government of India side?
Yeah, as I mentioned that we brought out this white paper, and in that white paper we have included this inductive charging as well, inductive charging both stationary and dynamic, and also even catenary charging. But one thing is that inductive charging is at very infant stage right now. You can say that it is below TRL level 3. So a lot of work is happening across the globe, but it is still at the laboratory stage. So it has to be scaled up. Definitely there is a potential for such technologies in the country. So I think research has to scale up.
Okay, thank you. I have a quick question to Nick. AI application, right? How it will improve the utility operators? Utility operators, how it will useful for the AI tools?
Okay, thank you. Thank you for your question. So there's, I mentioned a few in my presentation just before, but there's probably a couple that actually appeal to me that I really like. I'll go through 3 of them maybe. The first one is around disaggregation. So we, from our perspective anyway, we're heavily invested in disaggregation algorithms using machine learning and other techniques. And so what that is about understanding what's happening behind the meter. So for instance, understanding if there's an EV charging, is there, what sort of appliances are existing behind the meter, is there a pool pump, is a person charging an EV at a peak time when really they should be charging an EV at a non-peak time. And so what we like to do at Oracle is actually blend that AI. Remember what I said, AI doesn't exist in a vacuum. So we like to blend that AI with a larger business process. In this case, the way we've blended that is we've got our CX solution and we infuse it with behavioural science. So we use behavioural science techniques to actually send appropriate messages to consumers to suggest that they need to shift when they charge their EV, as an example. And that's called behavioural demand response. A second piece of AI that I really like is around outage avoidance. So what we do on this front is that we model storms and the damage they cause on your network. And based on that, when there's a new weather pattern coming in, you input that weather pattern into your AI algorithm, and what spits out is the likelihood of where damage and outage could occur. So for a utility, this allows a utility to actually strategically place their crews in the spots where they think it's most likely for an outage to happen. And the beauty of this particular solution here is that you can run hypotheticals. So a utility can actually run a hypothetical about if a storm came from this direction, what is my most likely outage point in my network, and as a result, be proactive and reinforce your grid at that particular point in time.
Yeah, thank you very much. DST also has a national mission on interdisciplinary cyber physical systems. We are also using artificial intelligence techniques for the smart grids operation. MeitY also working on the artificial AI mission. It is recently launched.Maybe we can work all together.
Absolutely,
for this.
that sounds
Thank
fascinating.
You.
Thank
Quickly,
you.
I will have a quick question for the Krishan Singh, Om Krishan Singh. How this NAMPAD program benefit the smart grid in the country? In a 1 minute actually.
Sir, this NAMPAD program actually, it is from the lab, from clean room to the field. All the device level, then product level, everything has been developed. And in the smart grid especially, we have developed many technologies, including the support vector machine in islanding detection and its protection. So it is specifically developed for including AI and all, and it has been deployed in Kerala, one of the districts. So it is working. So this is all. We are working on this, including this blockchain, AI, to make more safer and reliable this grid system.
Thank you very much. I take one question for Sathyanarayanan Sankaran. You have done, I am seeing your waste management, startup, Bioman, Biocycle, Mayor of Bangalore. We would like to listen from you, what you would like to say to the audience in the last point.
No, I think the speakers have said all of the things that need to be said. What I'd like to see is if more of you can come forward, and how do you bring a collaborative mindset in solving problems? Because it's very hard to solve all this on your own. How do we bring this together? I was just speaking with Suresh Babu also. Is how do we put together pilots, and how can you participate in some? Whether you're a large operator or a small innovator trying to bring things together, MeitY and DST are very well empowered to support all these kind of innovation. So the ecosystem matters, and I think the more we understand who are the people who we can support and bring together, the better off we'll be, because these challenges are very large. We are transitioning and growing and trying to get to net zero. It's not one or the other, it's all three put together. So we need all the innovators that can come together to do this.
Thank you. Before giving to the chair, I would like to thank Dr. Reddy Kumar Pillai Saab and Dr. Renu Suri and Shashi and their all team members accommodating us. On behalf of DST and all our members, I would like to thank you, sir. Thank you very much. I now request Dr. Srivastava to give a 2 minutes concluding remarks. He is a master of smart grids. He helped DST for all activities in the area of clean energy. Thank you, sir. Thank you.
Thank you, Dr. Reddy. First of all, a lot of thanks to you for conducting this session and interacting with the audience as well as the panelists. I am actually very fortunate to have been involved with MeitY, Indo-US Science and Technology Forum, and also with DST in certain capacity. So I can see the linkages, I think, which have to be created further, because they are working on similar mission through different efforts. I think MeitY is supporting NAMPAD program, which Dr. Om Prakash Singh told, and we are in the committee, so we interact very closely with him. They are doing wonderful job, not only from device level, new device level, but also its application to transportation and then smart grid applications, even railways, boats. You have seen one example, flexible solar they have used. So wonderful job they have done. DST has numerous initiatives, I think we must appreciate. E-mobility was talked by Dr. Suresh Babu. And I'm really happy to know that they have brought the standards with BIS, which will be really guiding the further development in the country. And I think people can get benefited out of that. There are always questions that when it will be feasible and when it will be cost effective. I think that depends on the government policy and also the initiatives from different sectors. And if you have heard the pre-budget speech of Honorable Finance Minister, emphasis have been large. There is a large emphasis given on clean energy, EV sector development, use of renewable at charging station have been specifically mentioned. And they have also earmarked very large amount of corpus for startup, innovators. I think our friend Ganesh is helping some of these startups to grow. So, and then we got benefited from the initiatives taken by Powerledger, Jemma Green, Web3 platform, which is wonderful platform. I think in future, India actually is going ahead with the local market. You will come to know in the next set of presentations, and your will be quite useful in that. And then Nick, I think this is a very, it's very important area, ML, AI ML. We worked 30 years back. That time, possible applications were very little. We were talking about only forecasting or state estimation my student did in 93, AI ML application. But now it has got the boost, it has real application, because there is a hardware available, there is a software, proper software available, computing resources, optimizations are available to implement it. So I think it will have great future, and almost every government is working on in that direction. Everywhere you apply. Only the curse of the new technology has to be avoided somehow. People are a little afraid of that, so that we have to be very careful. So, and then the last one, I think Sathyanarayanan, all efforts in bringing international collaboration, helping utilities in different projects are really commendable. So thank you very much. It was very, very informative and also very exciting presentation from all the panelists. I personally got benefited out of their presentation, and I'm sure all of you must have got some benefit out of the various ideas they have given. And you can interact further, seeking opportunity to working together, whether you are from utility, academia, or industry. So thank you very much. I once again thank all the panelists, our moderator, Dr. Reddy, and all of you for very active participation. Thank you.
Thank you so much to our esteemed panelists and wonderful audience for your engagement and involvement. Special thanks to Dr. Reddy for making this session a success. I hope this was a very insightful session. Now I would like to request ISDF President Shri Reddy Kumar Pillai to present the mementos to our distinguished speakers. Chair of the session, Dr. S.T. Srivastava from IIT Kanpur. Sir, please. Yeah. I request the panelist and sir for a group photograph. Dr. S.C. Srivastava from IIT Kanpur. Dr. J.B.V. Reddy from DST, thank you very much, sir. You moderated the session very well. Ms. Jemma Green from Powerledger, thank you very much, Ms. Jemma. Mr. Nick Birell, thank you very much, Nick. Dr. Om Krishan, thank you very much, Dr. Om, for joining us. Dr. Suresh Babu, thank you very much, sir. And last, Dr. Sathyanarayanan, sir. Thank you very much, Dr. Satya.